All right, so we're going to talk a little bit about Ohm's Law more in like a mathematical perspective. Just a couple things about Ohm's Law. It shows the relationship between ohms, wattage, voltage, and ampage. It's used daily by electricians out on the job site, and hopefully you watched the video before this video on why and how they use it. But we're going to talk about it a little bit more. So electricians use this formula to install the correct gauge of wire to carry the load. Yesterday we talked about knowing what you're trying to wire, and using the correct ampage circuit for that, and in addition using the correct wire from the circuit breaker to the actual device that you're trying to wire. Millwrights use this when installing machinery and heavy equipment, and all construction workers must verify that their cords are correctly adequate or the proper gauge for the power tools being used. So this kind of comes into play a lot. It's really not super difficult, but we're going to dive into it a little bit. So a couple things. We'll call this the letter I. That's going to refer to current, okay? So on your little triangle, this is the Ohms triangle. This is going to be our current. So anytime you hear the word current, we're going to call it the letter I. All right, so I'll just underline that up here too. And this is, could be amps, okay? So anytime they talk about current or amps, it's going to be labeled by the letter I in this triangle. V is going to represent voltage. Could also be labeled by the letter E, as we see right here in E volts, but V obviously is voltage, so if we're talking about voltage, that's going to go in this. And then R is going to be the power, or sorry, R is the resistance, and P is going to be the overall power, okay? So looking at a couple things, that's how that triangle breaks down. So now let's actually look at the various formulas. So here's the three different triangles. So we have voltage, we have current, and we have resistance. Voltage is equal to the current times the resistance. That's what this means. Voltage is equal to the current times resistance. So remember, I represents current, R represents resistance, okay? So then for this one, we have current is equal to voltage divided by resistance. And then resistance is equal to voltage divided by current. So I gave you these on this sheet. We're going to refer back to them because I know that they're kind of hard to see. But these are just simple mathematical restructures of an equation. So if this was our base equation and we wanted to know what the current was, because the current is being multiplied by the resistance, to get this by itself, we have to divide by the resistance. That's where we get this from. But if that confuses you, that's okay because I gave them to you. All right, so now just a couple examples. So this first one, we have 110 volts. We don't know what the current is, but we know that the resistance is 2,200 ohms, okay? So the question is, a 110 volt wall outlet supplies power to a strobe light with a resistance of 2,200 ohms. How much current is flowing through that strobe light? So obviously this is what we're looking for, and we have multiple choice stuff down here, but we need to figure out what was given to us. So they gave us E, or the voltage, and they gave us R, or the resistance. Okay, so we have the voltage and the resistance, and we're looking for the letter I, obviously down here. So this is going to be the equation we use. We're going to use current is equal to voltage divided by resistance. So current is equal to 110 volts divided by 2,200 ohms. And when you plug that in your calculator, you're going to get 0.05 amps. Okay, remember current, as we saw earlier, back to the front sheet, current is what flows on a wire conductor like water down a river, and it's measured in amps. So you get 0.05 by dividing 110 and 2,200, and then it's going to be amps. On to number 2. So a CD player with a resistance of 40 ohms has a current of 0.1 amps flowing through it. Sketch the circuit diagram and calculate how many volts. Well, we're just going to look for the volts, okay? So we're looking for the volts, and that's going to be equal to, if you go back to your formula, volts is going to be equal to the current, which is letter I, times the resistance, okay? So our current is 0.1 amps, so we're going to do 0.1 times 40 ohms. So your voltage is going to be equal to 4.0, and that's going to be number 2. And that's what you would do all the way down. Just identify what you have, whether it's volts, current, or resistance. Plug them into the formulas that you have up here, and you'll have what you're looking for.